This lesson is on the tangent ratio. I'm all about saving you guys as much time as I can, so if you see the example that you're working on below, you can download my app referenced in the video caption and use it to quickly navigate all of my Math 10 lessons and examples. So the tangent ratio function, what is it? Trigonometry is the study of math that deals with triangles. Tri signifies three sides of the triangle. There are three main functions that are used in trigonometry: the tangent function, the sine function, and the cosine function. Functions are equations that help you solve something you don't currently know. So that's like a formula in science. So let's define the sides of a right triangle. A triangle with one of its interior angles equal to exactly 90 degrees is called a right triangle. One of the remaining two angles of the triangle must be chosen as the angle theta. This is a Greek letter of the alphabet. Theta is typically the variable letter name given to an angle that one does not know the value of yet, but any other letter could be used. After one of the remaining two angles of the triangle is chosen to be theta, the sides of the triangle can now be labeled. Let's look at the next slide for the labels given to the sides of the right triangle. So follow my cursor here. Looking at the bottom right, tangent, sine, and cosine ratios can only be used with triangles that have one angle equal to 90 degrees, i.e. a right triangle. This square here signifies that that angle, that interior angle of the triangle, is exactly 90 degrees. So that's very important to look out for. Unless it tells you in the question, or the angles labeled with this square, or is labeled as 90 degrees, do not assume that it is a 90-degree angle. This long side length here, we always call the hypotenuse of a right triangle. So from there, we would choose our angle theta that we're looking at. So we can only be choosing from this angle or this angle. In this case, on this slide, we'll label this angle, the bottom left one, as theta. Now, only after we've chosen theta can we label the adjacent and opposite sides of the triangle. So this side length here we call adjacent to the angle theta. I like to think of it as it is right next to that angle. So you have the opposite of the hypotenuse on one side of the angle right next to it, and then the adjacent on the next side of the angle. And then the last side length is called the opposite side to the angle theta. So we would label that as the opposite side. To help me remember that, I like to think of myself sitting in that corner where theta is and then looking out into the center of the triangle, and then eventually the side that you look out at, that is the opposite side. On this slide now, the only thing I've changed is I have, got to go back here, I was just getting my cursor. The only thing I've changed is labeling this angle now as theta. And that is a big deal when labeling these side lengths now, because now that this is theta, this side length actually becomes the adjacent side length to that angle. And then again, if you're sitting in there and looking out, you're looking at this side length as the opposite side length. So remember, it completely depends on what angle you choose as theta, and then you stick with that angle. So it doesn't matter which of the two angles is chosen to be theta. However, as I mentioned, once the choice is made for a given problem, what angle is chosen to be theta and labeled, do not change which angle is theta, and consequently which sides are defined as opposite and adjacent. It is very simple to find the other angle in a problem once theta has been solved for by a given trigonometric ratio function, tangent, sine, or cosine, since all interior angles of any triangle always add up to 180 degrees. For a right triangle, 90 degrees has already been used up in that total of 180 degrees. Thus, there are only 90 more degrees to be used up. For example, if theta is found to be 30 degrees, that means the last angle must be 60 degrees. That is, 90 minus 30 equals 60. We will now look at how to use the tangent ratio function for finding lengths or angles that are unknown in a right triangle. Important reminder, the tangent function can only be used for a right triangle, that is, a triangle with one angle being exactly 90 degrees. The tangent ratio is defined as tangent of some angle, tangent of theta, equals opposite side length divided by adjacent side length. This is our function or formula. Find the tan button on your calculator. It should be on all scientific calculators and definitely on graphing calculators, but you likely do not have a graphing calculator yet, as this is typically only in grade 10 math that you first learn the basic trigonometric ratios. So find that tan button. Again, I've just rewritten what the tangent ratio or formula is below. When you press the tan button on your calculator and then put in a value for the angle and press enter, your calculator will give you a number, usually a decimal number. Given the equation above, looking at that equation, the decimal number is equal to the opposite side length divided by the adjacent side length of that right triangle. This means if you know one angle in your triangle and you know the adjacent side length in your triangle, that is, you know two of the variables in that equation, you can then find the third and last variable in that equation, the opposite side length. What's powerful about the tangent ratio is that it can be used for any sides of triangle, since it doesn't matter to the tangent function what the side lengths actually are. It only cares about what their ratio is and what the angle is. It just calculates the value for the ratio of the sides. Opposite side length divided by adjacent side length. This is why it is typically a decimal number, since it comes from a fraction or ratio. Let's look at some examples. So for example 1 of our tangent ratio, find side length x in the below right triangle. Note that there is no square shown in this triangle or 90 degrees written there. However, it is given in the question itself that it is a right triangle. Therefore, you can assume that this angle here is 90 degrees. However, do not assume that unless it is told you explicitly or a square is drawn here, which would be another way of explicitly telling you that that is 90 degrees there. So for this triangle, we have a known angle, 35 degrees. We have a known side length of 5 centimeters and an unknown side length. We need to find this side length x. Relative to the 35 degree angle now, this 5 centimeter side length is called the adjacent side. And relative to that same 35 degree angle, this side length x is the opposite side. Now we can write our tangent function. Tan theta is opposite side length divided by adjacent side length. And we fill in what we know. So our angle is 35 degrees for theta. Our opposite side length is our x, our unknown, and then our adjacent side length is 5 centimeters, so we put a 5 in for adjacent side length. So note that we know everything in this formula now except for one item, one variable. Therefore, we can solve for what that one thing is using algebra. So how do I get x by itself? How do I solve for x? Well, I need to get rid of this 5. What's the only way I can get rid of this 5? Well, I multiply by a 5. on this side. I multiply on the top, and therefore these two 5s will cancel out. But I can't just go and multiply by a 5, if you remember how algebra works, on the right-hand side of this equation. That's like if I had 1 equals 1, and then I multiplied the right-hand side of the equation by 5, I would get 1 equals 5. Well, if I multiply the left-hand side by 5 as well, I would get 5 equals 5. That is one of the most important things to realize about algebra, and how you can use it to isolate variables, find out the things you don't know. So we need to multiply the left-hand side by 5. Now those 5s on the right-hand side will cancel out, and we just get x equal to our 5 on the left-hand side times tan 35. Now in your calculator, you can just type 5 tan 35, and it will know to multiply the 5 by the tan 35. Remember, tan 35 degrees is just a number when you put it in your calculator. And it will be 3.5, rounding to the 10th place. And since we started with 5 centimeters here, we have 3.5 centimeters as our opposite side length. Side note, tan 35 equals 0.700. If you do not get 0.700 rounded, when putting tan 35 into your calculator, double check that your calculator is currently in degrees mode. There is another unit of angles called radians, and so somewhere on your calculator it might say rad to indicate it's in radians mode. So make sure you have it in DEG degrees mode. You will learn about radians likely in a latter or in your next math class in grade 11. Let's look at example 2 for the tangent ratio. So let's find the side length A in the below right triangle. Again, we're given that this is a right triangle, so we can assume that this angle here is our 90 degrees. It certainly looks like that's the only angle that would be 90 degrees. So relative to the 20 degrees, this A side length is our adjacent side. Relative to the 20 degrees, this side is our opposite side. So now we can write our tangent ratio, because we're dealing with the opposite, the adjacent, and some angle. So we have opposite side length, adjacent side length in our tangent function, and tan. Let's fill in what we know. So 20 degrees is our angle theta, 17 is our opposite side length, put that in for opposite side length, and A is our adjacent side length. So we put in an A for adjacent side length. Let's solve for A. So let's get A by itself, and it has to be in the numerator. We don't want to solve for 1 divided by A. So I don't like fractions. I try to get rid of those as soon as possible anyway. The only way I can get rid of this A here is multiplying this right-hand side by A, and of course I can't just do that. I need to do the same to the other side to keep the equation balanced and not actually change it. And so A will cancel on the right-hand side, and we're left with A times tan 20 degrees equals 17. Well, we're one step closer. We have A in the numerator now, but now it's stuck to this tan 20. How do we get rid of that tan 20? Well, the only way to get rid of something that you're multiplying by is divide it by tan 20 on the left-hand side there. And we can't just go and divide just that by tan 20. We have to divide the right-hand side by tan 20 as well. Sorry, my divide by is not quite lining up with these guys, but imagine on the left-hand side that this fraction is just underneath the left-hand side, and this tan 20 here is underneath the 17. And so we finally get those two, tan 20, they're the same thing over same thing. They cancel to just a 1. So you have A on the left-hand side, and then 17 divided by tan 20 degrees on the right-hand side. And so if you put in your calculator 17 divided by tan, and then it'll usually give a bracket right away, put in 20, end your bracket, and you'll get A equal to 46.7 centimeters. So example 3 of the tangent ratio. Find the side length B in the below right triangle. So relative to the 38-degree angle, this side length here is the opposite side length. And this length here, relative to 38 degrees, is the adjacent side. So we're writing out our tan function now. We know what our adjacent side is, our opposite side length, and our angle. So plugging into our formula, we have 38 degrees is our angle. We have B is our opposite side length, and 9 is our adjacent side length. We want to solve for b, so we need it by itself. So we're going to multiply 9 on the right-hand side. Those 9s will cancel. Do the same thing on the left to keep the equation balanced. So we get b equal to 9 times tan 38 degrees. Plug 9 tan 38 degrees, just 38 in your calculator, and you'll get b equal to 7.0 centimeters. Example 4 of the tangent ratio. Find the side length b in the below right triangle. And sorry, this should say find the angle b in the below right triangle, of course, because that is what's labeled here. Slight mistake I made. So remember, again, this is find angle b in the below right triangle. So we have relative to angle b, this is our opposite side length. Relative to angle b, this is our adjacent side length. And so we'll write our tangent ratio, and plugging in what we know, tan b, so in this example, relative to our other examples, we don't know what the angle is, but we know what both the side lengths are. So 9 is our opposite side length. We plug in a 9 for opposite, 14 in for adjacent. And now, how the heck do we find out what b is? This is something that's a bit new. There's a it's typically when you hit second and then that tan button, above the tan button in print, the second function of that button should be tan to the -1 or arctan. Think of it as kind of the opposite of what tan does, or think of it as it's what you use to get rid of tan when doing your algebra here. Tan to the -1 then can cancel with just that tan, and you're just left with a b. You can think of it that way. So we would take the tan to the -1 on the left-hand side, and that'll cancel out that tan. And then, of course, we do the same thing on the right-hand side, and then make sure that 9 over 14 is put into brackets here. So this is a little tricky to explain, but you can kind of think of it as when you don't know your angle, you use the arctan or tan to the -1, second button tan, and I'll show it here down below. What you actually put in your calculator is that second tan, which is going to be tan to the -1. Your bracket will start automatically. Type in 9 divided by 14 and make sure you end your bracket then. So you're taking the arctan or inverse tan or tan to the -1 of 9 divided by 14. And then that's going to give you a number, which is your degrees, your unknown value of b angle. So take that slide in a bit, and this was kind of the trickier one to remember in this entire lesson, is using the arctan, inverse tan, tan to the -1 in order to find out your angle when you don't know your angle, okay? And make sure you can get that 32.7 degrees when you plug in tan to the -1. Again, on your calculator, on mine anyway, you push the second button and then tan. That'll bring up tan -1, and then you plug in 9 divided by 14 and you end your bracket, and you'll get 32.7352, etc. And just rounding to 10th place, that's what you get there.